Hi everybody, today we are going to continue talking about how to find the slope of a line. So here is what we talked about yesterday. First thing we talked about is all different ways to describe the idea of slope. So the big one that we talked about yesterday was rise, which means how much did they move up or down, over run, which is side to side movement. Now we could also describe it as change in y values over change in x values, which in shorthand is written delta y over delta x. Remember, delta is just a variable that stands for change in. So all of these ideas we talked about in terms of looking at a graph and seeing if we could determine what the slope was. We also talked about using the slope formula, which is y2 minus y1 over x2 minus x1, and those values come from any 2 points from your graph. So notice that y2 minus y1 is just your change in y, and x2 minus x1 is your change in x. So it all ties together. So today we're going to be focusing more on this change of y over change of x, and we're going to be finding the slope from a table of values. All right, so here we have a table of values for a linear function. So remember, these are all coordinates. So we're going to be looking at these values to see if we can figure out the change in y over change in x, which tells us the slope. So what we're going to do is we're actually going to look at the difference in y values between any 2 rows. So let's say we go from here to here and here to here. So we'll always start with the change in y values. I see to go from -6 to -3, I need to add 3. So it's a +3. The change is +3. And to go from -2 to -1, I add 1. So if I do change in y, or delta y over delta x, it's 3 over 1, which gives us a slope of 3. Now this would work for if we found the change in y and change in x between any 2 of the points in our table. So let's try it again, and let's use the change from this row to this row. So to go from -3 to 12, we have to add 15. So our change is +15. And to go from -1 to 4, that change is +5. So same thing, I can do delta y over delta x, and I get 15 over 5, which gives me the same exact slope. So it doesn't matter where you're looking for the change in y or change in x, as long as you're looking at the same 2 rows on both sides. And remember, we are just really doing the slope formula here. Here's y2 minus y1, which is 15, and x2 minus x1, which is 5. All right, let's try another one together. So let's look at our table of values and see if we can determine the change in y. Let's go from here to here, and then the change in x on the same 2 rows. So from 3 to 5, my change in y is +2, and from 1 to 2, it's 1. So delta y over delta x is 2 over 1, which gives me a slope of 2. Just to double check, let's say between here and here. Between -3 and 3, that is a change of 6. I go up 6. And from -2 to 1, that gives me a change of 3. So when I do change in y over change in x, I get 6 over 3, which is also 2. So I know that our slope is correct. All right, go ahead and pause the video and see if you can give this problem a try. All right, go ahead and check your work. I decided to find the change from here to here. So to go from 4 to 2, I'm actually going down 2, so my change in y is actually negative. And then from here to here, from -2 to 0, it's a change of +2. So if I do delta y over delta x, I get -2 over 2, which is -1. All right, so now I want to talk about a few special cases. So here you can see that we have 2 separate graphs, and on each graph we have 2 lines that never cross. These are lines that we call parallel. So parallel lines, which you can see right here, are lines that never cross. Okay, so let's see if we can look at, find some way to generalize how we know if lines will be parallel. So I'm going to actually look at the slope between these two lines, and we'll do it just by looking at the graph. So remember, we can pick two nice points. I'm going to pick these 2 points because I know what they are, and I'm going to do rise over run. I see that my rise is -3 and my run is 2. So this line has a slope of -3 over 2. Remember, we always do vertical over horizontal, change in y over change in x. Now let's look at the slope of this line. Let's use this point and maybe this point. So I can see here that my rise, since I'm going down, is -3 and my run is 2. So this line also has a slope of -3 over 2, which is interesting. Now let's look at this other one. Let's make sure it's not a coincidence that our lines have the same slope. So let's start with the line on top. Let's find the slope using, how about this point and this point. So here my rise is 2, my run is 3, so my slope is 2 over 3, change in y over change of x. And let's do this one from here to here. So my rise again is 2 and my run is 3. So my slope again is 2 over 3. So now you can see that it's probably not a coincidence that these two lines have the same slope and these two lines have the same slope. So I'm wondering if you can pause the video and generalize, make a generalization about the slopes of parallel lines. Go ahead and pause the video. What can we generalize about the slopes of parallel lines? Okay, so hopefully you generalize something along the lines of parallel lines have the same slope. So it can go both ways. If you see two lines that are parallel, you know that their slope should be the same. Or if you see two slopes that are the same, you know that the two lines will be parallel. So you can use it going both ways. So that is one special case to watch out for in terms of slope. Two more special cases. The last two we're going to talk about. What do we do with the slopes of horizontal or vertical lines? So this is an example of a horizontal line. So when we're looking at the slope here, let's see if we can actually kind of try to follow our process of picking 2 points and do rise over run. So I have 1 point here, which we can use, and 1 point here. So if I'm trying to do rise over run, what I notice here is that, well, my rise is nothing. I'm not moving up or down to get to my next point. So for rise over run, my rise is 0, and then in this case my run is 3. However, it doesn't really matter because if my numerator is 0, my slope is just going to be 0. So all horizontal lines, as you can see, have a slope of 0, which makes sense. They are not slanted up, they're not slanted down, they're perfectly flat, so therefore they have a slope of 0. But this can also be confirmed just by looking at the graph, or you can pick 2 points and do the slope formula and you will actually get a slope of 0. Now let's look at vertical lines. This one's a little bit weirder. So let's try to do that rise over run again. So let's say I choose to use like this point and this point. So to get from here to here, I see that my rise is 2. So my rise is 2. But my run, I don't have to move side to side. So my run is actually 0. So hopefully you remember that there's a very important rule with fractions. You can never, ever, ever have 0 in your denominator. It's impossible to divide something by 0. So when you see this, we say that this number is undefined, and therefore our slope is actually undefined as well. Okay, so anytime you have a vertical line, the slope is actually undefined. The slope does not exist. If it helps, you can think of it as it's so steep that we can't even define it. So once again, horizontal lines have a slope that is 0. Vertical lines have a slope that is undefined.